Alright, what's up everyone? Welcome back to the channel. I'm Tokenicer and I'm here to bring you guys in-depth news, analysis, and insights from the digital asset space, along with covering the progressive tokenization of the world. So I'm bringing you guys once again another Terramoon exclusive from my weekly show on there, Tea Time with Token. In this week's session on Tea Time, we took a look into the Aleph Zero network. This has been one of the layer 1s in the crypto and DLT space that's really been gaining a lot of attraction, and for good reasons. From their focus on secure private smart contracts to their multi-layer protocol and all the connections within the masterminds behind their team, we really went under the microscope into all of that in this week's episode. So if you guys want full access to this deep dive, in addition to everything else like Brian's TA, first access to any deep research I find, and my weekly show of Tea Time with Token, where we do a bunch of deep dives into a lot of strong fundamental projects, be sure to check out Terramoon Ventures, and I'll be sure to link it right down below. And as always, if you guys do decide to join, I do have a discount code, which is Tokenicer, for 25% off. And as always, none of what you're about to hear or read, or even what you get if you join Terramoon Ventures, is any form of financial or investment advice, as none of us are financial advisors. But now that we got that out of the way, let's get right into it. So today we're going to be taking a look into Aleph Zero for our tea time this week. So this is a project I've kind of discussed here and there just very briefly. I haven't ever actually taken a really deep dive into them, or at least publicly. So you guys are kind of getting my first takes on Aleph Zero and kind of what they offer as a protocol. So for anyone who's not familiar with the project yet, Aleph Zero is basically another layer 1 project. So there's a lot of these in this space, right? You've got layer 1s like Ethereum, Polkadot, Cardano, etc. There's tons of layer 1s out there, and I'm sure most of you guys are familiar with what a layer 1 is. It pretty much, well, a smart contract layer 1 to be exact, pretty much lets you build applications on top of it. So say DeFi applications or NFTs. And so what Aleph Zero is trying to do is pretty much make a layer 1 protocol that solves this trilemma. And this is kind of the target most layer 1s have. I don't want to say recently, because I think many projects have solved this trilemma. It's just which ones can solve it best at this point. Which ones are able to scale the most without having to compromise being decentralized or risking security. And so what Aleph Zero is really focused on is security and privacy. So let's just take a look at fundamentally how they work first. So they operate as a directed acyclic graph. So in the world of blockchain and DLT, most times if you're a layer 1, you're either going to be a blockchain, which I'm sure everyone's familiar with. Pretty much transactional data get fit into each block, and then every network's block confirmation varies depending on size and time, versus a directed acyclic graph where it's not quite as chronological, but rather when data enters the network, it gets validated between these nodes. And what we've seen is that directed acyclic graphs do tend to scale better for enterprise purposes. We've seen many of these occasions. So let's take a look at IOTA, for example. IOTA is being used within the EU health and defense systems, and they're collaborating further on European infrastructure. They are a directed acyclic graph. Constellation Network, they're working with both space agencies and the Department of Defense. They're also a directed acyclic graph, and they handle crazy amounts of data. Hedera Hashgraph, they have tons of applications from some of the biggest companies in the world building on them. Another directed acyclic graph, and we haven't seen much of this level of adoption in terms of building real applicable, well, products on blockchain networks. It's all been, well, not all, but the large majority has been directed acyclic graphs. Large reason for this is because they just scale better. They don't scale linearly. A blockchain, pretty much every block gets added to the front of the last block, versus a DAG where you see it just bounces between different network nodes. So scaling is a lot easier in terms of transactional speed and fees, and also lower energy consumption because of the fact that you're not going to have nodes that pretty much look back onto the last previous block every single time. So they are a permissionless and public DAG, so pretty much anyone can join or leave the network without any voting or any, I guess, hierarchy. And as we said, a large focus of Aleph Zero is privacy. And so how they do this is they're actually a proof-of-stake network, and much like a lot of directed acyclic graphs, they solve the Byzantine fault tolerance kind of issue. So this is seen in a lot of directed acyclic graphs that pretty much because it's much more of a almost, I want to say, random validation. You don't know who might be a bad actor, and so this is kind of an example of what Byzantine fault tolerance would look like. So let's say there's a big empire and there's a bunch of members that are coordinating to attack and take over this empire. But to do so, because it's such a large empire, it needs a complete coordinated effort. If even one person decides to not partake in this, I guess, event, it doesn't work. And so what happens if one party says, yes, I'll be on your guys' side, but they end up running off? Well, that initiative kind of fails now, right? And this is very similar to how Aleph Zero or any other directed acyclic graph would kind of work, in the sense that you might have malicious actors within the network, but even then, you still need to have the network somehow come to consensus and reach that level of finality and agreement within the network. And so they did this through combining both zero knowledge proofs, so ZK proofs, and smart multi-party computation. And we'll get a bit into what these terms kind of are, but just as a kind of brief summary of it, it basically lets you verify someone else's information without needing to know their private data. But before we really look into kind of the technicals of Aleph Zero, let's kind of look at the highlights of what their layer 1 is. So they mentioned oracles. That's, pretty common with most layer 1s. You kind of need to get an oracle within the network to bring real world data into there, right? They actually titled their consensus protocol, I believe, Aleph Byzantine fault tolerance, so still ABFT, but this is actually a peer-reviewed consensus protocol, and you guys can actually find this peer review right on this page. And we actually see that this is right on the Cornell University page to peer review. So there's definitely some, I want to say, smart people looking into kind of the ins and outs of this network. Fees are also very low, and as we talked about, this has become kind of the case with most of these newer layer 1s now, right? They scale much better in terms of fees and also in terms of speed. There's also a hub and spoke model, so that is pretty much an easy application and integration to Aleph Zero. Interoperability is also a pretty key focus of how they want to build out their network, and we'll get into how they achieve their interoperability in a little bit. Smart contracts for both public and private, and then again, scalability. Network can handle billions of users and high volume of transactions. And so this is kind of just a little outline of how their consensus works. Basically, much like how Algorand, if anyone was here for that breakdown, in their peer proof of stake consensus, there are random validators that are selected. So in Aleph Zero, it's also very similar. There's a random group, well, not a random group, but validators can be selected at random. While a lot of their kind of consensus protocol is, I want to say, very heavily technical, some of it, if you compare it to other directed acyclic graphs within the space, you do see kind of similarities, but also how they build upon certain aspects to improve on it. Now, about MPC, so multi-party computation, and zero knowledge proof. So let's take a look into what these are. So basically, zero knowledge I have two examples here. So this one is Alice is a prover and Bob is a verifier. And with ZK proofs, Alice can prove to Bob that she knows for a fact that the contents of the exchange information without revealing those contents to Bob or any other party. So simply put, it kind of means Alice is able to prove that the fact from, let's say, this transaction is true without revealing private parts of the transaction. What this example was showing was that pretty much Alice is able to prove that the transaction is true just based on kind of the information she gives Bob without having to reveal the private information that may not want to be stored on chain. And so that explanation might be a little confusing. So let's take a look at this one. This one, again, uses Alice and Bob. These are probably the most common names when it comes to having examples with consensus protocols and just things within blockchain and tech. But anyways, so this one basically shows Bob is standing outside of a cave and Alice is in this cave. There's two paths in this cave that both lead to a door. And pretty much what this example of zero knowledge proof shows is that, so I've highlighted each step here in different colors, or just making it easier to understand. So there's a single entrance but two pathways, pathway A and pathway B, that connect to a common door locked by a password. So Alice wants to prove to Bob that she knows the passcode to the door, but she doesn't want to reveal the actual code to Bob, so Bob can't come in, right? So to do this, Bob decides to stand outside of the cave, and Alice walks inside the cave, taking one of the two paths, so either A or B, they both lead to the door. Bob then asks Alice to take one of the two paths back to the entrance of the cave, so this could be chosen at random. And so if Alice originally took path A, and then Bob asks her to take path B, that means the only way she could have gone back out of the cave using path B is if she knew the password, right? And so this process can be repeated constantly to prove that Alice has knowledge of the password on the door and it didn't happen just at random. So after repeating it, let's say, I don't know, 20 times, it's a pretty high probability and the network can have pretty high confidence that the information is true without having to reveal all of the information, right? And now, multi-party computation is rather similar. These are not quite interchangeable terms, but they definitely do kind of have a very similar use case. And here is a just short video explaining multi-party computation.
Secret computing keeps data encrypted while it is being processed. Here's a simple example of how the XOR secret computing engine leverages secure multi-party computation, or MPC. Consider a data scientist who wants to compute the average salary of 3 employees, but the employees do not want to reveal their individual salaries during the process. First, the data scientist specifies the function to be calculated by Infer's XOR secret computing engine, in this case, a simple average. Then Infer distributes the function and random numbers to the players, starting a distributed private computation. The computation leverages a concept called additive secret sharing, which is the division of a secret amongst a group of willing participants. The process encrypts data while it is in use. In our example, Alex's 45,000 is split into 3 randomly generated secret shares. Alex keeps one of these secret shares for himself and distributes one secret share to each Bree and Kathy. Bree and Kathy also secret share their salaries while following the same process. When the secret sharing is completed, each person holds 3 secret shares, one from each participant. Each secret share provides no useful information on its own. Secret shares only reveal the underlying data when all of them are recombined. This also makes them quantum resilient. Each participant locally sums their secret shares to calculate a partial result. The partial results are then recombined, summing the complete set of secret shares. The recombined sum divided by the number of participants yields our average. Alex, Bree, and Kathy's average salary is $60,000. So, XOR is never exposed to sensitive data, and the participants never reveal their private salaries. But the correct result is there. That is why Infer's XOR engine.
Alright, so that was a nice brief little explanation of what multi-party computation does, right? It basically makes it much more secure and gives users the kind of comfort and freedom to not have to reveal all of their data for, well, there's multiple purposes, but for example, let's say you want to buy from an online store, but that store requires you to be 19 or older. Most times how this is done is you send in a photo of your ID and then they verify if you're of age or not. At this point, they know your name, your address, your exact age, and your date of birth. With MPC and ZKs, pretty much what could happen is the computers wouldn't need to know your name, right? That has no relation to your age and whether you can buy that specific product. All it really needs to know is your date of birth. It doesn't even need to know how old you really are. It just has to know if you are over the age of 18. It doesn't need to know if you're 20, 22, just needs to know above or below 18. So that is just one small example of what ZKs and SMPC is able to do. But moving on, let's look further at kind of the actual underlying protocol itself. They've done this in terms of building out their protocol in a pretty interesting way. So they've built out a layer 1, but there's a layer 2 just natively sitting over top of it. And this is what they call Liminal. And you guys can see here. So up here is the Aleph Zero layer 1. And then layer 2 is the private multi-token custody. And Liminal is right here. So again, Liminal is very focused on privacy. And we'll get into exactly the full spectrum of what Liminal does, but this is kind of what allows them to not only have secure private smart contracts, but also interoperability to a certain scale. Now, this isn't the level of interoperability that Quant or even Constellation might offer in terms of true multi-chain, though who knows. If we take a look at their team shortly, we'll just see just kind of the level of expertise and connections that these people have. What we're able to see is they've integrated some other networks in here. So Polkadot, Ethereum, Binance Smart Chain, and I believe I did read somewhere that they do plan to add more within kind of their network ecosystem soon. Looking at Liminal now, this is what they call hybrid privacy solution. And pretty much what it means is this is talking more on ZKs and MPC. So further explaining ZKs, it pretty much says that it allows one party, the prover, to produce concise proof that can be used to convince the verifier that the prover is performing only correct computations in its private data. So we briefly talked about this, right? And the most important point is that nothing about the prover's personal data is revealed to the verifier. There's also multi-party computation. This, again, ties in very similarly. It's keeping sensitive information off-chain on several nodes. And so this data, the private off-chain data, this can only be accessed if all the nodes conduct a secure handshake, or in other words, unanimous consensus. So the whole network has to agree that that data can be shared onto the network. Otherwise, it just stays off-chain and private. And so these two solutions really complement each other, with ZKs allowing for basic transfers, but they're incapable of dealing with multi-user interactions. So if it goes to a larger scale where, let's say, there's 4 or 5 parties, ZKs might not scale or work as well. And then on the other hand, the problem with MPC would be that it's just very slow. It also does not scale well in terms of speed. So what they're saying is with Liminal, they've combined both the strong aspects of the two to take away from the kind of cons that these offer. Now there's a ton of tech and kind of programming jargon in kind of how this is really built, so we're not going to look into that exactly. But what we will look more into is kind of just the extent of what Liminal offers. So beyond just kind of privacy and storing private data off-chain, they also say that Liminal will kind of open this new paradigm of applications that are accessible on multiple chains. In other words, interoperability. And so here it says that it's possible to write smart contracts on Ethereum or Near while keeping private state of this contract on Aleph Zero. And then this part is rather interesting, how they say this. So in short, they envision a multi-chain future. If you're looking for an efficient, scalable, and decentralized Layer 1 network, choose Aleph Zero with a native privacy framework. And it says if you'd prefer to stick with your existing environment, so kind of, I don't want to say legacy, but kind of where blockchain and DLT is at today, where, you know, there are kind of some interoperability sources, though there are also lots of risks when it comes to these interoperability sources with bridges and wormholes. But they say by all means do so. Then you might want to consider taking advantage of Liminal, powered by Aleph Zero, to enable private computations. So pretty much what they're saying is maybe you still want to build on, I don't know, another network like Ethereum, Solana, AVAX. What if you could also leverage the power of Liminal in terms of enabling more privacy in your network, but also interoperating to Aleph Zero's network? Now, in terms of ecosystem, their ecosystem is still rather early, as I don't think there's an ETA exactly on mainnet yet, but they are a lot younger than a majority of Layer 1s out there. But we do see a lot of VC investments within their network and also kind of industry players. Now, this board also has a lot of connections to their team, which we're going to get into right now. So their CEO is Matthew Nymerg. One thing to notice about the team at Aleph Zero is they're very smart people. They have multiple PhDs, as we can see here. And their team is also absolutely massive, as you guys can see in this little photo. But let's quickly take a look at Matthew and kind of his previous experiences. So because most of these guys are kind of very academic focused, much of their work is focused in research and academias. So you're not going to see as many private sector connections to things, say, like Google or what's another big private sector company? Like Apple. But there are definitely some outliers, as we can see here. Matthew was at IBM, and kind of his role was in hardware, but they had also collaborated with NVIDIA. What Matthew's role at IBM was focused on kind of building and expanding on the world's most powerful supercomputer. So that's saying quite a bit, right? But beyond that, he also founded Cardinal Cryptography. So this is kind of a company that is focused on incubating projects, but this actually has tons of ties to the Aleph Zero core team. And as we see up here in these screenshots, it's actually the core developers of Aleph Zero that had created Cardinal Cryptography. And so this kind of works as almost like an incubation for projects building on Aleph Zero. So some projects do have kind of this kind of, well, I shouldn't say some, I think many projects do have this. So for example, Constellation has their flight program, and then Hedera has the HBAR Foundation. And, you know, this is good in terms of attracting more builders to come into your ecosystem and build, and giving them the kind of guidance and possibly funding to do so. Now, beyond just working at IBM and founding Cardinal Cryptography, because these guys are all very academic focused, they also have academic papers, right? So I'm not gonna pretend and sit here and talk like I understand what most of these papers really talk about, but they do seem very, I want to say, mathematical and scientific. But what's very interesting is, if we look at these papers, there's some repeating names of other authors and researchers that Matthew is working with, right? There's two that pop up consistently, D.J. Bates and D. Mehta. So I looked up both of these. D.J. Bates, he seemed like he had a lot of experience in terms of writing papers and everything, but it wasn't really anything that just really stuck out at me. But when I looked at D. Mehta, you guys will possibly be quite surprised at the connections here, but take a look at this. So currently, he's actually the head of applied machine learning research for investment management at BlackRock. This is the same BlackRock that just recently partnered with Coinbase and has over $10 trillion in assets under management. We also see he had spent about 3 years at Vanguard. This is another huge investment firm, as their senior manager in investment strategy and machine learning. And so we see kind of his expertise in sciences here, right? In terms of machine learning and data scientist. So, while this guy isn't directly tied to Aleph Zero, he does have a lot of previous history with Matthew, who is the CEO of AZERO. So who knows, we could potentially see some collaboration there in the future. These leads are about as far as they go from what I've seen so far in terms of actual leads that are put out there and not just speculation. But anyways, moving on, let's look at Adam. So again, you guys have probably seen how I previously share the backgrounds of the majority of kind of teams and connections within crypto, and that's usually by their LinkedIn profiles, right? Well, because these guys are so academic focused, their LinkedIn profiles really don't do them justice, and I feel like what really kind of shows the scale of operations that these guys work with is looking at their publications. And well, from here we can see multiple of these actually do seem to tie towards the whole objective for Aleph Zero and the idea for distributed ledger technology. And then just briefly looking at kind of the rest of their team, many of these do seem to just be people that had probably done really well in their academics and landed an internship and eventually got hired by Aleph Zero. But some of these guys do have very significant connections. Damien, he was actually in the International Collegiate Programming Contest, and from what I've read, this is one of the biggest kind of contests in terms of programming and developing out there, and he qualified as a finalist, I believe. Lucas also spent some time at IBM, much like Matthew did. I'm not going to try to pronounce this name because I'll likely butcher it, but their creative lead had spent some time at CodeWise, which was I believe one of the fastest growing companies in Europe, and was founded by Rob Grin, who is now the CEO and founder of MetaHero. Michael, this guy has a pretty interesting background, and I would argue possibly the best out of anyone on the team, really. And a large reason for this is, if we look here, so we see he had started out at Deloitte, spent 2 years there. Deloitte being one of the big 4 accounting firms. It's a pretty big position to be holding, right? Corporate finance advisory. And then PwC, another one of the big 4 accounting firms, as head blockchain and manager for digital strategy. So pretty relevant experience to what he's doing now, right? And then this is the kind of biggest point. Maybe there's some bias here because of the quant maximalism, but what we see here is he was a senior advisor for SIX Digital Exchange. And so the Swiss Digital Exchange, SDX, this is founded by 6 who also manages the Swiss Interbank Clearing System and the Swiss Stock Exchange. So to see such a position like this is rather interesting. And, there's definitely, I believe, some significance to it. Whether this ties into kind of how Aleph Zero might blend into SDX in the future, we'll have to see kind of how that goes and how deep these connections really are. But I think just seeing that is a pretty good sign of kind of the people that are paying attention to Aleph Zero. And then their community lead, Kirby Ong, he had also spent time working with the communities at Algorand and Phantom, which are both pretty big Layer 1 projects now, right? Well, maybe not Phantom, but Algorand. Their business relations lead had spent time working at multiple large insurance firms and most notably Santander Bank. One of the other advisors, he was a business advisor for the Prism Group, and the Prism Group pretty much uses the tools of contract theory, game theory, market design, social choice theory, and monetary economics to design customized solutions for DLT and blockchain projects. So you could say like consulting and advising. And what's really interesting is down here it says the firm's research has been presented at DARPA. So these are the guys who had a huge role in building the internet itself, right? The Federal Reserve, IBM, Microsoft, Pantera Capital, Polychain Capital, A16Z, Union Square Ventures, Hachette, Harvard, MIT, USC, Stanford, and more. So that's quite a list, right? You've got some Fortune 500 companies in there. You've got some of the top academias around the world in there. You've got some of the biggest investment funds and VCs. And then you have government agencies like DARPA and, well, I don't want to say they're not official government, but public agencies like DARPA and the Federal Reserve. So while the board, or not the board, but the team for Aleph Zero is very focused on kind of academics, they definitely do have some very strong connections in here to, BlackRock, Vanguard, IBM, Silicon Valley, Santander, and then kind of some indirect connections to kind of these guys like DARPA, the US Fed, and then SDX. Now, to just wrap it up, as usual, we're going to look at the tokenomics as kind of the last little pillar we look at. So they go by the ticker AZERO, and their tokenomics are kind of interesting because unlike most crypto assets out there, they actually don't have a total cap. They have a fixed inflation rate, but it's not by a percent. It's by actually a fixed amount, which you really don't see often. And this amount is always at 30 million every year. And so maybe this sounds kind of bad because in the first year, that means 10% of the total supply gets released. But as you scale it out, as you guys can see here, I've done the math. The kind of inflation or the effect on the inflation just gradually diminishes over time as the 30 million relative to the total supply just grows smaller and smaller. So year one, you have 330 million, but then year two, you've got 360 million. So inflation, the rate of inflation has already dropped to 9.1%. Fast forward another year, 390 million. So it's dropped to 8.3 now. Year four, 420 million, 7.7. And then you see by the time we get to year 15, it's as little as 3% inflation. How it works is 90% of the inflated tokens, so 27 million tokens, get rewarded to validators and the overall community for staking. And then 3 million, so 10% of it gets redistributed back to the ecosystem and for kind of just development. So that's kind of the inflation for Aleph Zero, right? Maybe it seems like a big deal to some, but I really like the way they've structured this, honestly, because over time, the inflation amount is just going to mean less and less. The actual use cases for Aleph Zero is collateral for liminal wrapped assets. So again, liminal is that protocol that gives them a sense of interoperability, and maybe we shouldn't say, well, it is interoperability. It might not be full-scale interoperability, but it's wrapping assets. And so you're going to need collateral for that, right? You need the same amount of locked value from one chain to bridge onto the other chain. So I think this is a very interesting mechanism, because if this is used at scale, there could be a lot of value that's just locked as collateral for wrapped assets. It also gives you discounts for using the liminal bridge. So there'll be a fee to using that bridge, and well, you get discounts using the AZERO token. And then you also get discounts on their DEX, decentralized exchanges that launch into the AZERO ecosystem. You can pay for fees in Aleph Zero or AZERO and earn a discount on it. And then obviously it's used for staking, as it's a proof of stake network. So how the staking works again is the staking rewards are distributed from 90% of the inflation, and then 10% of that inflation is for ecosystem development. You can either stake onto a validator, or you can delegate your tokens to stake. And so currently we see that the circulating supply at the moment is only at about 75 million, and staking is at 222 million. But that's about it for our little breakdown into Aleph Zero. So if anyone's got questions now, you guys can feel free to unmute your mic and fire away.